All right, so we got some low quality lighting here, but I don't care, it's fine. I gotta explain. So this morning, so I had to do some things. Last night I was up till like 3 in the morning, and then today I built a closet after I made that video. I realized I made that video with an error, I think. So number 8, I had to change it to unlisted, and then I'm gonna have to make another one because let's watch that video. Alright guys, so number 8 of the Lambda Cube. My phone screen is broken, so I can't do all the upload settings. But anyway, we have a vector which depends on a type and then a natural. So we have a type dependency and we have polymorphism. But then we have a function that maps over the vector, giving us a vector of one type with the same length based on the vector of another type of the same length when you also give it a function that from that first type to the second type. So there you go, number 8. That involves polymorphism, type dependency, and then vmap, a map for vectors, which is type operators. And you have all 3 of of the Lambda Cube. See you guys next time. Okay, so how many of you guys can guess where I messed up, like where the error is? So let's think about this for a second. So we have vector, right? And what is vector? It's a higher order function basically, because it's like a constructor, but think of it as like a higher order function that it's creating a type, not an actual value, but an actual type that a value can be assigned to be that type. And how do you create that type? You have to give it another type, and then you have to give it a natural, right? So we're creating a type and it's dependent. So really I was wrong because I said it was polymorphism, but it's not polymorphism yet. Okay, so you have a type that depends on another type, so that's a type operator. And then you have a type that depends on a natural, which is not polymorphism, that's just dependent typing, right? So that's two of our Lambda cube. So the example is it's correct because it contains all 3, but the vector part, that's the one that doesn't include the polymorphism yet. When I create the vmap, it uses the vector of type A, where A can be anything, and natural, and then it also takes in a function that takes an A and returns a B, and it uses those 2 as inputs to then return a vector of the same length, but where the type is B instead of A. Now, if you think about that vector map is something that's actually taking a value which has type vector A5 or whatever it is, and then it's returning one that's type B5 or whatever, right? So whatever this vector map is, it's a function that's taking values and returning values, so it's not actually really constructing new types. So, but it is relying on what A and B could possibly be. So because of that, it basically is polymorphic because it's relying on, in order to define what it is as a function, it's relying to create that relies on the definition of another type. So that's where that's why that part of it would be polymorphism, because it itself is a value, but it depends what the value is defined as depends on a type. So I think what I had was backwards, because what I said in that original Lambda Cube Part 8 video was wrong, because I was saying that the definition of vector was polymorphic, and then I was saying that vmap was like a type operator, but you're not really creating a new type. Like you are indirectly, but not in the definition of vmap are you defining what a new type is. You're defining what a new type is using vector. Vector is the thing that depends on A or B or whatever you pass into it. because you're using the definition of vector to create, whether it's vector of A or vector of B, you're using that definition. So that's the definition. Vector is the part that is a type operator and a type dependent. And when you use it, the expression itself to use the function vmap to map something onto a vector, that's gonna be polymorphic, I would say, because you're not really, it's not, one of the parameters isn't just a raw A or B, but one of the parameters is like give it a function that takes an A and then returns a B, and though but since they're parameterized to be open. So what you're saying is, to define vmap, you can give me a function that takes some type A and returns a type B, and then it has to take in a vector of A with a natural and return a vector of B with that natural. And when I express that as the parameters for it, I'm saying A and B can be anything. So basically, you can rewrite that, and you can basically say that the function that takes an A and returns a B, that's polymorphic, or that's being passed in. That's part of the definition, part of the parameter, but it doesn't need to be named. So this is actually a very interesting kind of complexity when you start dealing with lambda calculus, and then you start dealing with like higher order functions and calculus of constructions, because you start understanding like, okay, so this is how this all works. Because you can have something, say in Haskell, for example, or Agda or Coke or something like that. You can have something that looks like it's saying, hey, I'm an array of type A, but then I'm a function of this. But really, that definition itself is a function that takes a type and returns something. So you're not always explicitly defining, because there's these different levels of abstraction going on. You're not always explicitly putting everything in like the arrow format. But it's kind of easier to conceptualize a function when it's an arrow format, because you're saying, well, this is the input and that's the output, right? That's what a function kind of is. It has an input and an output. But when you parameterize something, that's what you're doing, but you're not always, you're not always referring to the two levels of abstraction the same way, But that's really what's going on, and so that's what I'm trying to make explicit. I'm trying to really define what is going on here. What is the thing that's technically polymorphic? And that's a good thing to question. That's a good thing to point out. What exactly is the definition of polymorphism? Does vmaps count as a polymorphic function, or do you have to say that it's indirect and that A arrow B is the polymorphic function, right? And I would say, well, I think vmap is, because it's the parameter that contains all that information. It's its definition that contains all the information saying, well, if you give me an A arrow B, and that's where A arrow B is being defined, that's where those variables are being constrained. They're not being constrained elsewhere, right? It doesn't matter that vector uses A or B or C or D or any other letter. When I'm defining vmap, I can change it. I can say, give me a X type arrow, Y type, where X and Y are types, but then you have to give me a vector of X and then return Y. And that, now vector can use A's and B's, but see, my X's and Y's are still there in vmap's definition, but they don't appear anywhere else, right? So you're still that's where they're coming in as this variable that's saying, well, give me a type and I'll give you a function back. So that's why I would make the claim that vmap is polymorphic. But again, my original video saying that it's the type operator part, and then that vector was somehow the polymorphic part, and the type dependent part was, I think, incorrect. It's vector should be type dependent and type operator, and then I would say vmap is the polymorphic part. So I apologize for that, and I guess that's what I get for trying to make a video on so little sleep and then having a broken phone and thinking, I need to finish that 8th video. But still, at the same time, needing to make sure that I actually have it properly explained, and I don't want to put false information out there. The whole point of this is to not confuse myself or anyone else. It's to learn how these types work, how to see, how to apply them, how to understand them when you see them, and then help others learn and get educated about them so that we can start building on this stuff. So I'm going to change that video to at least unlisted, if not private or deleted or whatever. It might just leave it as unlisted. And then we'll leave this as an example, and then I'm going to redo Lambda Cube number 8, the short. So that would be very good to do. All right. I will see you guys later, and I hope you have fun watching my low quality light video from my MacBook.